Okay. So, good evening, everyone. Welcome to the next live session for the course Characterization of Construction Materials. So, today we will discuss the questions which is related to the topic spectroscopy. So, what is spectroscopy? It is another characterization technique which uses the spectra, that is, including the visible light, then infrared, microwaves, X-rays, etc. We use all those rays or light from the spectra, and we use them to analyze our material, either by the absorption of those radiations, or by the emission of those radiations, or by analyzing some behavior uh, when we introduce these radiations to the materials, like vibrations or rotations, etc. So using the uh, radiations, when we try to characterize or when we try to understand the properties of the material, it is known as spectroscopy. So without further ado, let me share the screen and share the question. Okay. Okay, is my screen visible? Is my screen visible to all? If you do not respond, then basically this live session is not useful. Okay, thank you. If there is any disruption in my voice or in the video, please let me know, because I will not know unless you speak up. Okay, so let's move to the first question. Okay, the first question is a fill up the blanks question. The wavelength of heat radiated from human bodies is of the order of microwaves, radio waves, UV rays, or infrared. So, what is the order of the wavelength of the heat radiated from human bodies? Option A, microwave. Option B, radio wave. Option C, UV rays. And option D, infrared rays. Obviously, human bodies emit radiations or emit heat, right? There's no confusion about that. And what is the order of the wavelength? Okay, radio waves. What about Mehna? Are you responding? Okay, seems like she's not in the chat. Okay, so let's move to the correct answer. So the correct answer is option D. So Javed, just uh, understand that the order of the wavelength of the heat radiated from human body is not in the order of radio waves, but in the order of infrared rays. I think Professor had also mentioned a scene from the movie Predator, just to make you remember or understand more evidently. In that particular movie, that alien species understands the presence of the human based on the infrared order wavelengths which is generated from the human body. So it is always the infrared wavelength which is generated from the human body when the human body emits heat. Okay, let's move to the next one. Backscattering of electrons happen when the external electrons hit the dash of the atoms of the sample. So, what causes backscattering? So, the external electrons obviously hit our samples, or they interact with our samples to produce backscattering, to behave like a backscattering. So, these electrons hit the sample atom at the electrons or the neutrons or protons or nuclei to cause a backscattering. Okay, Javed goes with D. I guess Mehna is not responsive. So let's move to the answer. So the correct answer is D. You are right. So the electrons hit the nuclei of the atoms and then undergoes a backscattering. So let's move to the next question. Penetration efficiency of the electromagnetic radiations increases with the increase in the density of the target sample. So our sample is there and electromagnetic radiations are introduced into the target sample. As the density of the sample increases, more and more electromagnetic radiations can penetrate into the sample. That is what the statement says. Okay, the correct answer is true. Let's move to the next one. So, the nuclear radiation shielding. So, in nuclear power plants, we have to shield certain areas because inside that some radiations will be emitting. So, nuclear radiation shielding can be achieved by creating a barrier wall with high density concrete. So, this high density concrete, in the production of that, the aggregates used in this design of high density concrete are dash bearing. What does the aggregates contain? That is a basic question. So, carbon bearing, or magnesium bearing, or iron bearing, or silica bearing. In the manufacturing of high density concrete or in the design of high density concrete, what type of aggregates are used? Is it carbon bearing aggregates, or magnesium bearing aggregates, or iron bearing aggregates, or silica bearing aggregates? Okay, the correct answer is option C. Iron, which is having very high density, is used in the design of high density concrete. So, iron bearing aggregates like hematite, magnetite are all used in the design of high density concrete. Iron is having very high density. That is why when you see backscattered electron imaging, C4AF is seen as the brightest phase in the case of all the hydration products. C4AF is brighter because it has iron content, Fe2O3 iron content. Because of that very high density phase present, backscattering of that region will be in a white color. Okay, let's move to the next one. The inner shell electrons can be knocked out by the ultraviolet radiations. State true or false. The question is, to knock out inner shell electrons, not the outer valence shell electrons, but the inner shell electrons, you can bombard the material with the ultraviolet radiations. Is that a true statement or a false statement? That is the question. Hitting the specimen or the sample with ultraviolet radiations causes the inner shell electrons to be knocked out. Okay, let's move to the answer. The correct answer is false. We need high speed electrons or X rays to remove the inner shell electrons. So, with ultraviolet radiations, you cannot knock out inner shell electrons. For that, we need high energy or high speed electrons or even X rays to remove the inner shell electrons. Okay, moving to the next question. So, this is a set of statements. So, choose the correct statements from below. So these all are related to various spectroscopic techniques. Unbalanced number of protons and neutrons in an atom results in nuclear spin. So this nuclear spin is very much important in the case of NMR, or nuclear magnetic resonance. So for a nuclear or the nucleus to spin, it should have unbalanced number of protons and neutrons. That is the first option. Then the second one, nuclear magnetic resonance technique uses infrared radiations for exciting rotations. Third statement, emission of certain wavelength results in excitation of an atom. So it becomes a high energy state. Option D, molecular energy is a sum of electronic energy, vibrational energy, and rotational energy. Option E, for conducting atomic absorption spectroscopy, the analyte atoms must be in gas phase. Okay, A and C. Let's move to the correct answer then. Correct answer is A, D, and E. It's not the. So actually, what happens in the C case? If an atom is there and it accepts certain wavelength or it absorbs certain external wavelength, then the energy increases. Then it becomes excited. Once it is emitting certain wavelength, then atoms come from the or move from the higher state to the lower state. So actually, the opposite happens when there is an emission of a certain wavelength. When it is emitting the wavelength, then it's not excitation which is happening, but the atom undergoes a electron transfer from high energy to low energy. So C is wrong. D, it's true. It has electronic energy and vibrational energy and rotational energy. And E is also true for atomic absorption spectroscopy, AAS. The analyte atom must be in gas phase. You cannot do an atomic absorption spectroscopy in a liquid or a solid. The material has to be in gas phase. That is very, very important. So the correct answers are A, D, and E. Thank you, Javed, for responding. Now, let's move to the next question. The UV visible light spectroscopy. X is used as a light source for UV measurements, and whereas Y is used as a source of visible light measurements. So, UV visible light spectroscopy, X is used as a light source for UV measurements, whereas Y is used as a source for visible light measurements. Identify X and Y. Any idea? Okay, let's move to the answer. The correct answer is unfortunately C. Here, this is a snippet from the slide. So here, deuterium discharge lamp is used for UV measurements, whereas tungsten halogen lamp is used for the visible light measurements. So it cannot be IR and tungsten film. IR is nowhere in this spectra, right? It's about UV and visible light. So it cannot be IR. It has to be something in option C and D. Among option C and D, option C is the correct one. Deuterium discharge lamp and the tungsten halogen lamp. Okay, let's move to the next one. What is a wave number? Wave number is the number of waves passing through a point in a given time, or reciprocal of the wave frequency, or reciprocal of wavelength, or the number of waves generated from a source in 1 second. So, what is a wave number? Anyone? Okay, let's move to the correct answer. Correct answer is option C. Wave number is simply the reciprocal of wavelength. That is 1 by lambda is wave number. This nothing much technical about it. It is just the opposite of wavelength. What is reciprocal of, sorry, not opposite, it is a reciprocal of wavelength, 1 by lambda. So what is reciprocal of a frequency? Frequency is c by lambda. So it has the velocity of light also there in it. So that is not a wave number. Wave number is simply the reciprocal of wavelength. Okay, moving on to the next one. It's a true or false question. For a molecule to be infrared active, it should have polar bonds. So only polar bonds in a system are infrared active. State true or false. Okay. Yes, the correct answer is true. So in this case, there is a dipole moment. So H and Cl both have, there is a dipole moment existing between these different atoms. So that is why HCl is a infrared active molecule. Whereas in the case of O2, there is no dipole moment. Both are the same atoms, O and O. So there is no dipole moment. So it's not an infrared active molecule. It's infrared inactive molecule. Okay, let's move to the next question. Choose the type of vibrations which causes charge imbalance in the system. So, symmetric stretching of CO bonds in CO2, symmetric stretching of the OO bonds in O2, asymmetric stretching of CO bonds in CO2, asymmetric stretching of OH bonds in H2O. What causes charge imbalance in the system? Anyone? Moving to the correct answer. The correct answers are option C and option D. Just remember that whenever there's a symmetric stretching, there won't be a charge imbalance. For the imbalance to occur, it has to be an asymmetric stretching. So the asymmetric stretching of CO bonds in CO2 and the asymmetric stretching of OH in H2O causes the charge imbalance. Okay, let's move to the next question. It's also a true or false question. The fingerprint region of a molecule is shown in the higher wave number span in IR spectra, whereas the functional group region occurs in the lower wavelength span. Is it a true statement or a wrong statement? Okay, so let's discuss about it. So here, if you see, this is higher wavelength region, sorry, wave number region. It is a lower wave number region. So there are two regions in IR absorption spectra, which is a functional group region and a fingerprint region. So the functional group region is in the higher wavelength area and the fingerprint wave number area, and in this region bands are characteristic of functional group. In the fingerprint region, it starts from 1300 to 900. That is in the lower. So I think it has to be false. Right. Yeah. Fingerprint region is in the lower. So this is the fingerprint region. So this is in the lower wave number region. So, and yeah, this has to be a wave number span. Then it makes sense, right? So this is a lower wave number and this is a higher wave number. Imagine, just remember, it's not wavelength, it is wave number. So in the lower wave number region, it is a fingerprint region, and all the other functional groups, it come in the higher wave number span. So let me correct it here itself. wave number. Okay, moving on to the next question. The equipment which brings out light rays in either in phase or out of phase. So, if you emit light rays, this particular equipment brings out the light rays as in phase or out of phase. Interferometer, polychromator, monochromator, or array detector. Anyone? Okay, so let's find the answer. The correct answer is interferometer. So polychromator is something which emits the light of different wavelength. Monochromator, which can emit only one wavelength at a time. Array detector means it detects all the wavelength or different types of wavelength. So interferometer brings out the light rays which is in phase or out of phase. Let's move to the next one. In specimen preparation for FTIR, that is Fourier transform infrared spectroscopy, dash is used as a dispersive agent for solid samples while pelletization. So for FTIR spectroscopy, we can do it in either powder form or as solid samples, as small pellets. So when we pelletize, sometimes the solid samples will not be coherent or it will not be forming properly. So we use something like a dispersive agent for effective pelletization. So, what is that dispersive agent? Is it sodium chloride or sodium bromide or potassium bromide or potassium chloride? What is the dispersive agent which is used in FTIR spectroscopy while pelletization? Okay, let's move to the correct answer. Correct answer is potassium bromide. Why do we use potassium bromide? Because it has no way or it does not interfere with the FTIR technique. It doesn't involve in the FTIR technique in the mid IR region. So we can use potassium bromide as a dispersive agent. What if it does interfere? Then the peaks corresponding to potassium bromide will also be present in the FTIR results, which will contaminate the results of our pure sample. So we need some material which will not interfere with our own result. So that is a potassium bromide. Now, moving on to the next question. In ettringite, octahedral silica is present, whereas in thaumasite, tetrahedral silica is present. True or false? Anyone? Okay, let's move to the answer. So the correct answer is false. So if you just see here, so this is a spectra, IR spectra. So if you see, this octahedral silica is such an extremely rare coordination state. It is must be indicative of either thaumasite or thaumasite containing solid solution. So this octahedral silica is attributed to the presence of thaumasite, whereas in the case of ettringite, it's the tetrahedral silica which is present. Okay, let's move to the next one. A nucleus with its spin aligned with the external field will have lower energy, and when it has a spin aligned in the opposite direction, it will have higher energy. State true or false. Anyone? Okay. So the correct answer is true, because when the nucleus spin, it's already spinning in one direction, and our external field is also in the same direction, then it will have low energy. But if our nucleus is spinning in opposite direction to the external field, then it needs to have in a higher energy state. It will be existing in a higher energy state. So if our nucleus spins in the same direction as that of the external field, then it has a lower energy. But if our nucleus spins in the opposite direction as that of the external field, then we'll have very high energy. So the correct answer, that's the correct statement. Okay, let's move to the next one. Match the following NMR signal features with the information obtained from them. So this is the last question for today. On the column 1, the several NMR features are given. That's number of signals, intensity of signals, location of signals, etc. And in column 2, several other informations are which can be obtained through NMR are given. That is number of protons, then types of protons, shielding state of a proton, etc. So what are the corresponding feature and the corresponding information obtained? Anyone? Okay, let's move to the correct answer. Correct answer is C, that is A2. Number of signals indicates the type of protons. What are the different types of protons present? Then, intensity of a particular signal, it indicates the number of protons of a particular type. Then, the location of a signal, it indicates how shielded a proton is. So, thank you. I again repeat, if you are not responding to the questions, it is not much useful. It'll just be a monologue. Let me stop presenting. Okay.